Welcome back everyone, and today I'm going to be showing you how I built this helmet in exactly 10 days. I was commissioned to make this helmet for an upcoming children's event, and I'm going to start off by saying 10 days is a very short amount of time to design, print, and paint a full helmet. But with that being said, I'm definitely up to the challenge, so let's go through some of these steps starting back from day one. These are the two images I was sent to reference for the design. So using just these two images, I'm turning to Procreate to design a two-dimensional diagram. Since the original image seemed to be the shape of an actual bike helmet, I went on Google and found an image of one, and that was my start reference along with the images I was sent in designing the other angles of this helmet. Now, although I'm referencing images, I'm left to assume certain angles in design based on the original images. Ultimately, I drew up these three different angles of what the helmet should look like. This diagram will be used in the next step in my process to make this helmet. Next, I need to find a model head size STL file. This will be used to get a more accurate representation of the headspace needed for the helmet. I searched on Google and found a free model head for sizing on thingiverse.com. I downloaded the model and opened my Shaper 3D to begin the 3D design process. I've imported our 2D diagram into Shaper 3D and then begin to outline the basic midsection of the helmet. Once this is made into its own shape, I use the imported sizing head to get a close enough match of how much space the head should have in the helmet. I was sent measurements of the person's head that will be wearing the helmet, but without me measuring in person and knowing the specific shape of the person's head, I'll try to make the helmet a tad bigger. I'd rather have it come out a little bigger than too small. Skipping ahead, this is the part when I project different lines and grooves that will be shaped into the helmet from the diagram. As I design each individual part of this helmet, I'll try to match up exactly what I've drawn out in the diagram and not stray too far from our original ideas. I want the helmet to come out as accurate as possible. With only 3 angles made in the diagram, the back of the helmet is completely up to my discretion based on the design flow of the rest of the helmet. As I design this helmet, I'm able to extrude, shell, align, scale, and mirror different parts to get the desired look I want in Shaper 3D, making this design process a breeze. After I've gotten pretty far with the design itself, I usually take a minute to just look at it and compare it to the original images and my diagram to make sure I'm still not going too far off course from the desired look. And now we're going back to my diagram to complete the fin and trace over the shape just like the full helmet and position it as well. I deconstruct the shape to get it as close to the angles on the image references. In this program, the sketches you create or the lines you make for each shape remain after you've extruded or pulled each shape from them. Getting some of these dimensions can be irritating as well as time consuming, but for the most part, this design seemed to go pretty smoothly. After this, I focused on the chin straps, the adjustment holes, and the placement of where they'll be. I made sure they were positioned in front of the ears, so the head strapped into this helmet should have a bit of wiggle room for the chin strap, although these may be individually printed later and reattached. At this point, the entire design has taken me about 2 hours to get to where I'm at now. The final thing that needs to be designed on this is the wave emblem in the middle triangle on the front of the helmet. This piece may be also later printed by itself and reattached due to its small size. After that, we're finished, and this will be our final design. Next, I need to cut the STL file for printing, and I'm going to use Autodesk Mesh Mixer to make those cuts. Mesh Mixer has always been a free 3D modeling program which allows you to edit 3D meshes. Here you can see I'm going to make my first cut in the middle of the helmet and add male and female connectors so the pieces can be put back together as one after all the printing is complete. One of the big benefits of cutting up larger prints into pieces and printing them individually is depending on the specific placement of your STL on your slicer, you can save time and print material using less supports. This heavily depends on what you're printing and the overall shape and size of your print. Before printing, you should always think strategically around your design and the parameters of your printer to be the most efficient. A shape must be selected when making male and female parts in the program. It can be anywhere from a square, rectangle, or cylinder shape. They will be placed into one side of the connecting part, then copied, but neither shall be moved from its original placement. Once this is complete, I'll be subtracting our connectors from one side of the helmet so that they leave holes the same shape and size, making that my female part. After, on the opposite part, we have the same connector shapes in place, and I'll size them down only by millimeters, then joining the 3 connectors with the main piece, making that my male part. This is the same process I will use for each piece that I cut from this helmet with a total of 5 pieces. I'll now be moving on to setting up my prints in my slicer. The side I'll be placing on the printer bed is the only even flat surface of the print, which happens to be the face where my female fittings were made. All other 4 pieces will be set up in a similar fashion with the most even flat surface facing my print bed, giving me the best bed adhesion and less supports I need. Other than that, I'll make sure my exterior temperature is at 235 degrees and my bed temperature is at 80 degrees, as I'll be printing with PETG filament. After all my pieces were set up in my slicer, I realized I had various different time estimates for each print, with a couple being over 24 hours. Adding all the hours up, my print time was roughly 136 hours and 5 minutes. Luckily, I have 3 printers and we can space this out to about 45 hours per printer, which is almost 2 full days of printing on each printer.
Yeah, you see something better, you know.
After all the printing was complete, I glued the 4 parts of the back of my helmet together, including the fin. Besides the residual from the glue job, each part of the print came out looking clean with no warping or distortion, and now I'm going to glue both of these parts together using Gorilla Glue. The grooves of the male connections fit into the female slots, and I'll press them firmly together. The glue sets in about under a minute, so be sure to dry fit before you glue. As soon as this was done, I used more Gorilla Glue to fill in the seams just to make sure when it dries we have a solid seam. These areas typically tend to become harder than the print itself. Next, I had to sand the entire helmet till the layers were smooth, and this took up a good portion of time. I also had to hand sand some areas that were really hard to get. Upon putting the helmet together and test fitting on my own head, I realized the helmet was a bit too snug and I couldn't fit it. I made a last minute decision to cut and expand the sides of the helmet. This animation basically shows what I did. I didn't film it because I was currently using my camera to film another project, but this ultimately gave the helmet ½ inch of room extra on each side, making it fit my head, which is around the same size I was given for the helmet. After, I glued the sides back on and sprayed it with filler primer and covered up dents with filler putty and continued to sand the full piece smooth. After I've sanded enough where everything is even and the creases are unnoticeable, it's time to move on to the inside of the helmet. So now, I'm going to line the inside of the helmet with fiberglass resin. First, I mixed a batch of it and then I poured it directly into the helmet and worked the liquid around the inside with a foam brush. Once enough of the liquid was applied, I used cut strands of fiberglass to stick to the inside of the helmet and left it to dry for a full 24 hours. Before this process took place, I lined the inside of the helmet with a layer of Bondo and sanded it smooth to help achieve a more clean finished look. And now we're on our last day, so this is clean as I've gotten the helmet so far, with the inside lined with our plastic dip spray, and now we're going to start spray painting the helmet. I'm still using colors based off the original image reference. Turquoise, green, and purple were the closest colors I had to match in my arsenal of paints. 2 layers of paint were applied for the green and the turquoise that I'm applying here, and I tried to make sure I didn't miss any spots and also gave both layers a good amount of hours to dry. And with this being pretty much the last day I have to paint this, I have one shot to make sure this comes out right. Next was hand painting the purple lining around the emblem and the lip of the front of the helmet. I thought about taping sections off to paint them, but realized in the end that would take too long. Sometimes having a steady wrist comes in handy, although it definitely takes a longer time with much more focus to apply. Then I was very careful painting the triangle space in the purple lining. After the entire emblem area was carefully painted in black, I painted the two extended edge pieces black as well, from the back of the helmet to the front. Each side also got a couple of layers of paint as well. I then used a plastic bag to cover up the rest of the helmet and sprayed just the tip of the fin purple like in the original reference photo. One of the last things I painted was the small emblem in the middle of the triangle, which was also a small piece that had to be reprinted just because it was too small to print to come out clear on the overall print itself. Once all the painting was done and I had pretty much all the details I wanted to paint on this helmet, I let it dry for a few more hours, then I sprayed it with the can of clear coat. Clear coat typically will protect the paint at least from any minor scratches or the paint diminishing over time. So I did end up individually printing the straps for each side of the helmet, which were then bolted back onto the sides of the helmet, and I also used real helmet bike straps to just connect to my 3D printed ones. So that's pretty much it. There's a few parts that I wasn't able to film that didn't make it into the video, just because I had a very short amount of time with a lot of work to do if I wanted to meet my deadline. So that's going to be a wrap for this video, and I hope you enjoyed this full process of my 10-day helmet build. If you want to see the video for the event this helmet was used for, check the description below, and thanks for watching. Please like, share, and subscribe, and I'll see you in the next video.